Hello everyone and welcome back. My name is Mr. Cobalt and in this video I'm going to be going over how to predict the products of neutralization reactions. So let's get into this. So a neutralization reaction is typically going to be an acid-base reaction where the acid and base neutralize each other. They react together to form some salt and usually water. And so basically we're going to figure out what the products are. So we're going to treat this just like we did with the precipitation reactions. We're going to treat the acids as if they're ionic compounds, and we're going to, because they pretty much do ionize in water. But you got to remember that acids are, strictly speaking, covalent compounds. They're not ionic compounds, but they will dissociate, or I should say, ionize in water, and they'll act like ionic compounds. So we can do the same thing with regard to the precipitate reactions, where you take the outside ions and the inside ions, and you predict what your products are. And then after that, you want to make sure that the ions, the charge of the ions, balance in your formula, and then you can balance the formula, or you can balance the equation after you've got the formulas correct. I'm not going to do any balancing of equations in this one, but you can balance equations after if you want to. Okay, so let's start with the first one. So here we have HCl and KOH. So HCl is hydrochloric acid. That's our strong acid. And here is a strong base, potassium hydroxide. And so what we're going to do is, in all of these examples, we're going to assume that everything reacts completely. All the hydrogens react completely with all of the hydroxides. So we're not going to worry about, for example, in your H2SO4, is only one hydrogen going to react, or is both of them going to react? In this H3PO4, is all of these three going to react? Only two, only one? We're going to ignore that sort of question, and we're going to assume that all of the hydrogens react. Okay, so in that way, we can do our inside ions go together, our outside ions go together. Okay, so the hydrogen, again, we're going to treat this as if it's an ionic compound. It's not. It's not an ionic compound. It's a covalent compound, but it does ionize in water. So that's going to produce an H plus. That H plus is going to go with the OH minus. H plus and OH minus together gives you H2O. So we're going to get water as a product, and that's a liquid. And then we do the inside ions. We have the potassium ion with the chloride ion. The potassium ion has a +1. The chloride ion has a -1. So they're going to balance out 1 to 1. So that means that we're going to have KCl, aqueous. And again, talking about, we can do the solubility rules to make sure that this is aqueous, or if it's going to be solid, is it soluble or insoluble? And according to the rules for chlorides, your chloride ions are going to be soluble, except, of course, if you have silver or lead 2 ions. So we have a liquid and aqueous. Because of the liquid, this is a reaction. So the aqueous solutions come together to form a liquid. And so you are producing something that is not aqueous. So there's a reaction going on here. There's neutralization going on. All right, so for B, we have again our acid, sulfuric acid, and again, we have our potassium hydroxide. This is a strong acid, this is a strong base. They're going to react together. And again, the same thing, we're going to take our outside ions, we're going to treat hydrogen as if it's an ion, H plus. We're going to take the outside ions, so your hydroxide and your high H plus are going to go together. Again, that's going to form water. So H2O liquid. And then we're going to do the inside ion. So we have potassium and we have sulfate ion coming together. And for the potassium, that's a +1 ion, and your sulfate is a -2. So in order to balance the charge, we need two positive potassiums to balance the charge on your sulfate. So that formula is going to be K2SO4. And again, we can look at this. If we look at the rules, so for the solubility rules again, and your sulfates are going to be soluble, except for, of course, barium, lead 2 sulfate. Those are not going to be soluble. Calcium, strontium. So this is going to be aqueous. Next, we have HNO3, which is nitric acid. That is a strong acid. And then we have manganese hydroxide. This is a solid. This is not a strong base, even though it has hydroxide ion. Remember, it should be group 1 or group 2 metal. This is a transition metal, so not a strong base. So we're going to react the solution of nitric acid with the solid of manganese hydroxide or manganese 2 hydroxide. So again, we're going to take the hydrogen from the outside here to ions, so the hydroxide and the hydrogen together to form water again. So H2O liquid plus, now we take the two ions here, we have manganese and nitrate. So here we have a +2 charge on the manganese. How do I know that's a +2 charge? Because I have two hydroxides, and the hydroxide ion has a -1 charge, and I have two of them, so that's going to be a total of a -2 charge. That means that to balance that charge, the manganese has to have a 2+. So that has a 2+ charge. My nitrate ion here is going to have a -1 charge. So I'm going to need two nitrates to balance the charge on the manganese. So that's going to be Mn, NO3, 2. And as we said before, all nitrates, according to solubility rules, are aqueous. They're all soluble in water, so there's no solid, just aqueous, no precipitate here. Next, we have HCl, hydrochloric acid, a strong acid, and sodium hydroxide, a strong base. So we're going to, again, put the outside ions together. So H and OH go together to form water. H2O liquid plus we form the Na, the sodium and the chloride go together. That would be NaCl. So sodium has a +1 charge, chloride has a +1 charge. So that's going to balance out 1 to 1. So that's going to be NaCl. And chlorides are soluble with the exception of silver and lead 2 ions. So this is going to be aqueous. So far, these are all reactions. These are all producing something, and what they're producing is water. They produce liquid water, so there is a reaction going on these. Okay, here we have HF, that's a weak acid, and here we have a strong base. So again, we're going to do outside ions together, inside ions together. Again, I'm not saying that these are actual ions here in the acid, but they behave as if they are because it will ionize in water. So the next thing is, so I put the outside ions together. So the H and the OH go together. That's going to form water again. That's a liquid. And now I have lithium and the fluoride ion. The inside ions are going to go together, and that's going to form the ionic compound lithium fluoride. Again, the lithium has a +1 charge on it. The fluoride ion has a -1 charge on it, so it's 1 to 1. So LiF. And again, fluorides are going to be soluble in water unless you have like something like silver or lead 2. So this is going to be aqueous. Also, keep in mind that one of the solubility rules is that anything with a group 1 metal in it is going to be soluble. So group 1 metals and ammonia, I'm sorry, not ammonia, ammonium are going to be soluble. So here we have lithium, group 1 metal, so it's going to be soluble as well. So here we have our phosphoric acid and lithium hydroxide. So again, outside ions go together, H plus and OH minus. So again, we're going to get water. And then the inside ions go together. We have lithium and we have the phosphate ion. So you should remember that phosphate ion has a 3 negative charge on it. The lithium has a +1 charge. It's in group 1. So we're going to need 3 lithiums to balance the charge on one of the phosphates. So it's going to be 3 to 1. So that's going to be Li3PO4. And again, according to the rules for phosphates, if I could find that, phosphates are going to be generally insoluble. They're generally insoluble with the exception if you have a group 1 metal or ammonium, right? Because remember, the first rule of solubility has to deal with the group 1 metal. So group 1 metals are always soluble. So even though phosphates are generally insoluble, if you've got a group 1 metal, then that's going to be soluble. So that's going to be aqueous. And last but not least, we have our iron 3 hydroxide solid and our HNO3, our nitric acid. This is a strong acid. This is going to be a weak base, but that doesn't matter. We're going to do the same thing. So the outside ions go together, so iron and nitrate. Since the iron has a 3+ charge on it, how do I know it has a 3+ charge on it? Because I know hydroxide ions have a -1 charge on it. I have 3 of them to balance the charge on the iron. So that means the iron has to have a +3 charge. So if the iron has a +3 charge, here I have a nitrate ion that has a -1 charge. So I'm going to need 3 nitrates to balance the charge on the 1 iron. So that's going to give me the formula Fe3, and then, oops, I forgot. Fe, sorry, not Fe3. FeNO3, 3. So there's my formula for iron 3 nitrate. And then now I can put the inside ions together. So I have the hydrogen and the OH, and that's going to form H2O. That's a liquid. And again, nitrates are always soluble, so no precipitate here, no solid. It's going to be aqueous. And that, ladies and gentlemen, is how you write the products of your neutralization reactions. Again, after we have our products in the correct formula, the next thing would be to balance the chemical equation. I'm not going to do that in this video. If you want to know how to balance your chemical equations, please go to my videos on balancing chemical equations. I have plenty of those, so please look at one of those, and that should help you balance the equations. But this is enough for our video. The point of this video is to show you how to write the products for your neutralization reactions of acids and bases. What you'll notice is that in all of these reactions, water is produced. So we have water produced in all of them, plus some sort of salt or ionic compound that's produced. So this is backwards here. So, but you get my point. So that's it for this video. If you like this video, if you learned from this video in any way, shape, or form, this helped you in any way, then please, by all means, like the video, hit that like button, share the video with your friends, subscribe to my channel, hit that notification bell. When you do, make sure you click all so you'll be notified by all the videos I put out. And then finally, put a comment down below in the comment section. And so that way you can let me know what you think, ask me questions. If there's a topic you want me to cover in a future video, if there's a question or problem you want me to work out for you in a future video, I would love to do that for you. Thanks for joining me and have a great day.